17. Stabilized approach criteria. Stabilization height 1,000 feet AAL. Stabilized criteria. The following conditions must be satisfied before or at stabilization height. Landing checklist and briefing completed. Correct lateral and vertical flight path. In landing config. Thrust is appropriate for aircraft config and above idle, and aircraft is at target speed for approach. Flight crew does not detect any excessive parameter deviation. Sink rate greater than 1,000 feet per minute. Greater than 1 dot of localizer or glide slope. Greater than 5 degree from inbound course. Less than full high or full low of VASI, POPI. 18. Communication policies. Use of headset and speaker. Flight crew shall use anti-noise or throat microphone below transition area or 10,000 feet. Use headset and boom microphone for communicate with ATC during critical phase, from push back until top of climb and from top of descent until last engine shutdown. Headset will be used in high workload situation, from push back to top of climb and from top of descent until aircraft is parked and engine shut down. VHF-1 should be used for ATC communication. VHF-2 for company messages as standby and monitoring 121.5. VHF-3 shall be used for ACARS. At least one pilot maintain a listening watch ATC frequency at all times. 121.5 should be monitored by at least one pilot above 10,000 feet. 19. Thunderstorm. 3 stages of thunderstorm. Developing stage. Development of CB cloud. Updraft move aloft with the ascend of convective currents. Mature stage. Water drops start to fall. Downdraft falling in the middle of the cloud or storm, surrounding by strong updraft. Downdraft can reach 3,000 feet per minute and updraft can reach 6,000 feet per minute. This is the most hazardous stage. Decaying stage. This stage is marked by the end of continuous rain and sporadic shower. At the high level it may take anvil shape as upper wind spread out, below which there is strong downward vertical current such as wind shear. 20. Danger with thunderstorm, torrential rain, hail, severe turbulence, severe icing, wind shear and microburst, lightning. 21. Weather avoidance. Don't land or take off in the face of approaching thunderstorm. Don't fly under a thunderstorm. Don't fly without airborne weather radar into a cloud mass contain scattered embedded thunderstorm. Don't trust the visual appearance. Avoid by at least 20 miles any thunderstorm identified as severe or giving intense radar echo. Circumnavigate the entire area if the area has 6/10 thunderstorm coverage. Frequent lightning indicates severe thunderstorm. Thunderstorm with tops 35,000 feet or higher is extremely hazardous because of its continuous vertical development. Avoid flying over thunderstorm unless minimum of 5,000 feet clearance above is ensured. If possible, detour between storm cell rather than directly above. Keep radar tilted down to detect most severe cells. The safest path to fly parallel to a line of cell is upwind side. Avoid flying under the anvil. If ATC request flying into unsafe condition, request change of routing. For thunderstorm penetration, determine area of least precipitation, select straight path through the storm or perpendicular to the storm line. Try to maintain straight path, avoid turning to get out of the storm as quick as possible and reduce stress of aircraft. Most severe turbulence is between 10,000 and 20,000 feet. Change in thrust should be minimized. 22. Minimum flight altitudes. MEA, minimum en route altitude, the lowest altitude between radio fixes that meet obstacle clearance and acceptable navigation signal coverage. MORA. Route MORA provides reference point clearance within 10 nautical miles of the route centerline and end fixes. A grid MORA provides reference point clearance within section outlined by latitude and longitude. MOCA. Minimum obstruction clearance altitude, the lowest altitude between radio fix on VOR airway which meets obstacle clearance for the entire route. The lowest MOCA shall not be less than 2,000 feet. MSA, minimum sector altitude, the minimum safe altitude which provides 1,000 feet obstacle clearance within 25 nautical miles radius from navigation facility. 23. Contingency fuel. The fuel required for unforeseen factors such as deviate from fuel consumption data, weather condition, planned routing or cruising level. Contingency fuel must be the higher of 5% of the planned trip fuel, or not less than 3% of the planned trip fuel, provided that en route alternate airport is available. The en route alternate airport shall be located within a circle having radius equal to 20% of total flight plan distance. And the center of the radius lies on the planned route at a distance from the destination of 25% of the total flight plan distance, or 20% plus 50 nautical miles, whichever is greater. 24. What is dry runway and wet runway? A runway is dry if it is free of visible moisture and not contaminated. A runway is wet when the surface is covered by any visible moisture up to 3 mm depth. No significant danger of hydroplaning. A damp runway is considered wet. 25. Manual start. In the manual start sequence, FADEC has limited control. The FADEC open the engine start valve when the engine mode selector set to ignition and engine man start push button to on. Open the HP shutoff valve, and operate both igniter then engine master lever to on. Close the engine start valve, and cut off the ignition when N2 reach 50%. 26. Use of brake fan and brake temperature limit. When the brake fans are switch off, it takes several minutes for brake temperature to increase and math the real brake temperature. When the fans are running, the difference between indicated and actual temperature can range from 50 degrees to 150 degrees. Therefore, before takeoff, if the brake fans are running, if the brake temperature is above 150 degrees, takeoff must be delayed. Brake fan should not be used during takeoff to avoid foreign object damage to fans and brakes. If the brake fans are on and if the temperature of all brakes is below 150 degrees, turn off brake fan. 27. Rotation and tail strike avoidance. During rotation, the aircraft lift off at about 10 degrees of pitch, around 4 to 5 seconds after rotating. After the liftoff, PF targets the required pitch attitude. To monitor rotation, use the outside visual reference. Once airborne, PF control the pitch attitude target on the PFD. Early rotation occurs within rotating below VR. The result is an increased pitch attitude at liftoff, and a reduced tail clearance. 28. Turn after takeoff. Turn after takeoff at below 500 feet AGL, except for noise abatement procedures, are to be avoided and shall follow standard operating procedure from each specific type. 29. Optimum altitude is computed based on the current gross weight, cost index, temperature, wind. This flight level requires 5 minutes minimum cruise time at minimum of flight level 100. Optimum altitude is where the specific range is greatest or fuel mileage at a given weight and speed. Over time, weight decreases with fuel burn, the optimum altitude increases. At the optimum altitude, operating cost will be minimum in econ mode. It is also the cruise altitude for minimum fuel burn when in long-range cruise mode. Rec max is the recommended altitude based on the current gross weight and temperature, assuming anti-ice is off. It provides with a 0.3 grams buffet margin, a minimum rate of climb at max climb thrust, and level flight at max cruise thrust. This field is limited to flight level 398. 30. Soft altitude mode Alt Cruise. On reaching the cruise flight level, ensure that the FMA displays Alt Cruise, which ensures that aircraft is at cruise flight level and economy cruise Mach. The FMGS engages the soft altitude mode 2 minutes after the cruise flight level is captured and Mach stabilized. Soft altitude mode allows the aircraft to deviate 50 feet from the target altitude to minimize the thrust variation and reduce fuel consumption. 31. Icing condition. Icing condition is when the OAT on ground or after takeoff or the TAT in flight is at or below 10 degrees and visible moisture is present. Icing condition also exits when the OAT on the ground and for takeoff is at or below 10 degrees and operating on ramps, taxiways or runways when surface snow, standing water or slush may be ingested by the engines, or freeze on engines, nacelles or engine sensor probes. The engine anti-ice must be on during all ground and flight operations when icing conditions exist or are anticipated, except during climb and cruise when the temperature is below -40 degrees Celsius SAT. The engine anti-ice must be on prior to and during descent in icing conditions, including temperatures below -40 degrees Celsius SAT. Note: do not rely on airframe visual icing cues to turn engine anti-ice on. Use the temperature and visual moisture criteria specified the icing conditions definition. Delaying the use of engine anti-ice until buildup is visible from the cockpit may result in severe engine damage and/or flameout. 32. Stabilized approach requirement. The use of low-drag continuous descent approach technique up to the initial approach fix is encouraged. Timely configuration change is essential to ensure stabilized approach criteria are met. B. A comprehensive approach briefing including all particularities of the approach must be performed timely. C. Unstable approaches are a significant threat to operational safety. The majority of unstable approaches result from late configuration and/or poor energy management. Tailwinds can be a contributing factor and should be reported to AT when encountered during final approach. If the predicted tailwind at landing is greater than 10 knots or procedure glide path requires 3.5 degree or more. D. Unique approach procedures or abnormal conditions that may require deviations from the stabilization criteria, such as high approach slope, high weight circling with one engine operation, etc., shall requires a special briefing that shall be completed prior to commence the approach. F. Max speed limit in normal operation. O at 5,000 feet AAL, 250 knots. O at 3,000 degrees AL, 220 knots or green dot, whichever is higher. O at 2,000 feet AAL, 180 knots. O4 nm on final, 160 knots. Failing to comply with this speed limitation, OR must be summited with detail explanation.